Hello, boys and girls. We're going to be continuing on with our probability unit, and we're going to be on page 15 in our probability packet. And on page 15, you're going to see this page with a dice, or some call it a number cube up on the top here. And what we're going to do today is we're going to look at two different games. One is called cubed or 10 times. We're going to take a look at this game first, and our goal is to determine whether this game is fair or not. Okay, so the materials we need are a dice, which we have. This is a two-player game, so we're going to select a number cube with the numbers 1 through 6, which we have. Players are going to choose whether they will be the cubed player or the 10 times player. Players take turns rolling. The top number is the number used in a round. So when you roll the dice, the number that is on top is the number that we use. Both players use the same number. So the cubed player will cube the number, meaning the cubed player, whatever number it is, will multiply it by itself 3 times. The 10 times player, whatever number it is, will multiply it by 10. Whoever gets the highest score will win that round, and then we'll tally the wins as we go. So if we're using a dice or a number cube, the possible outcomes, and I'm going to kind of set this up in a different way, are 1 through 6, right? So we have 6 different outcomes. So what I'm going to do is I'm going to split this bar into 3 sections, or 6 sections, I'm sorry, 3 on each side. So we could possibly get a 1, a 2, a 3, a 4, a 5, or a 6. Whoa. Okay. Those are our possible outcomes. We're going to add a little bit more to that section a little bit later. So now we're going to think about, before we play, the theoretical probabilities of rolling each amount. So I'm just going to extend this line down because we're going to have 6 separate probabilities, because there are 6 separate possible outcomes. So the theoretical probability of rolling a 1 is 1 in 6. Rolling a 2 is 1 in 6. Rolling a 3 is 1 in 6. These are all going to be 1 in 6 because it's the same chances of rolling each number. Okay. Now, as we do the experimental probabilities, we're going to see that our numbers may be different. Okay. We're going to play this game, let's say, maybe 18. Maybe you'll roll 18 times because that's a multiple of 6. Now, I left some blank space here because we're actually going to go back and look at when would you win for each particular number and when would you lose. Okay, so, and then we're going to figure out if this game is fair or not. So what I'm going to do is I'm going to flip a coin to see which side I am, if I'm going to be cubed player or 10 times player. We'll see, because I don't want to pick one that might have an advantage or the other. So if I flip heads, I'll be the cubed player. If I flip tails, then you're going to be the cubed player. We'll see what happens. I flipped a heads. So I'm going to be the cubed player. This is going to be me. And then you are going to be the 10 times player. So what I'm going to do is I'm going to roll the dice, and then we'll figure out each one of our scores and see who wins that round. So I rolled a 2. First number is a 2. We'll see who wins. So me, I'm the cubed player. My score would be 2 to the third power, which is 2 times 2 times 2, which is 8. Your score would be 2 times 10, which is 20. So in this case, you would win. 4. Okay, I rolled a 4. So every time I roll a 2, you win. Now I just rolled a 4. Let's figure out my score. 2 to the third power is 4 to the third power is 4 times 4, which is 16. times 4, which is 64. Now your score would be 4 times 10, which is 40. So in that case, I win. That gives me a point. So every time I roll a 4, I win. A 5. Okay, so there's another number, different number here, 5. Well, I'm not going to circle that. So I'm going to mix you up here. All right, if we roll a 5, that means my score is 5 to the third power, which is 5 times 5 times 5, which is 125. And your score would be 5 times 10, which is 50. So again, I win again. So that gives me another point. All right, let's see. So if I roll a 2, 4, or 5, we already know who's going to win. Okay, roll a 6, a different number. Put the 6 right here. 6 to the third power is 6 times 6 is 36. Times 6 would be 180 plus 36 would be 216. And then your score would be 6 times 10, which is 60. So I win. So every time there's a 4, 5, or 6, it looks like I win, which is nice for me, I suppose. Now I'm going to keep track of how many of each number we get. Okay, we had 1, 2, 1, 4, 1, 5, and 1, 6 so far. So I'm just going to keep track over there. All right, roll a 3. All right, we're getting all the different numbers here. Roll a 3. So that means I would get 3 to the third power, which is 3 times 3 times 3, which is 27. And you would get 3 times 10, which is 30. So it looks like you win that round. Okay. That's you. All right, so I'm in the lead so far. See, we get a 1. Now I actually did not plan it out this way. I can't believe it worked out this way, but we got 1 of each number. So I roll a 1. 1 to the third equals 1. And 1 times 10 is 10. So that means that you win. So far we're tied. Now it's going to go a little bit quicker because we know whatever number we roll, we're going to know who wins because we've already figured out who wins for each number. Okay, got a 6. So who wins with a 6? I believe I win. Yep, the cube player wins with a 6, so I get a point. I'm going to count that 6. All right, next. Another 6. Believe it or not, another 6. So I get that point. Another tally for the 6s. 4. I got a 4. So that's another point for me. I got a 4, and I win. I get a 4. A 1. We rolled a 1. And that's good for you because you win when we get a 1 because you're the times 10 player. And that's another 1 or 1. If we roll a 5, well, that means I win. I get another point. So far it is 7 to 4. We're going to roll it 7 more times. Let's see what we get. A 2. So let's see. You get a point for a 2. So you're catching up a little bit. Let's see here. Another 1. That's good for you. You get the point for the 1. I'm just going to tally that 1 up here. And then you get the 1. So you've created a 7 to 6. Another 6 for me. I believe that's a good thing for me. 6 has been rolled 4 times. I get another point. 8 to 6. 8 to 6. 4 more rolls. Another 1. So that means you get another point. I'm just going to tally that 1 up there. You're down 1. You're down 1. Another 6. Another 6. So I'm going to tally that 6. 5 6s so far. I'm going to count that point for me. A 3. That's good news for you because you get the 3. Whoop, that should be a red. I'm just going to keep track of those colors like that. It's a red. And you get the 3.
Any student taking the late bus, please report to the cafeteria.
All right, so it's 8 to 9. This is the last roll here. 2. Look at that. 2. And then you get that point. It is tied. So it is 9 to 9 at the end. We have tied. Okay? So the experimental outcomes we can look at now. So each number, we're going to take a look at what was rolled for each number to see what happened. 1 was rolled 4 times out of 18. 2 was rolled 3 times out of 18. Not 6, 3 times out of 18. 3 was rolled 2 times out of 18. 4 was rolled also 2 times out of 18. 5 was rolled also 2 times out of 18. 6 was rolled 5 times out of 18. Now let's look at our theoretical probabilities out of 18 because that might be different. So we thought 1 out of 6, well that's 3 out of 18. So we were really close on 1. We rolled the exactly what theoretically we would get for 2, 3 out of 18. We were a little bit below our theoretical probability with the 3, it was 2 out of 18. 4, we thought was also going to be 3 out of 18, but it turned out to be 2 out of 18. 5 was also 2 out of 18, below what we thought it was going to be, and 6 was above what we thought it was going to be, 3 out of 18. Now, to determine whether this is fair or not, okay, we have to look at like when one player would win and when another would not win. Okay, so possible outcome. If we rolled a 1, who won? 10 times player would win. So I will say 10 times wins. Okay. If we rolled a 2, the 10 times player would win again. If we rolled a 3, again, the 10 times player would win. And if I rolled anything above a 3, cubed would win. Cubed wins. Cubed would win if I roll a 5. Cubed would win if I roll a 6. So I guess the question is now is this game fair? So you won 3 out of 6 of the times. There's 3 opportunities out of 6 for you to win. For me to win, there's also 3 out of 6 chances for me to win. Okay? So that means that we have an equally likely chance of winning. Each player has an equal chance of winning, meaning that it is a fair game. So it says, is your game fair? How do you know? We'd say the game is fair because each player has an equal chance to win. So let's say for whatever reason, the game was set up and the 10 times player won 4 out of 6 times and the cube player won only 2 out of 6. That would be unfair because the 10 times player had 4 chances to win where the cube player only had 2. This is evenly split, so this game would be fair.